Hi folks, and welcome to Strut Pricing 101. We put the pricing on the portal by item number, and so you folks can dive in and price these things on your own. And what I wanted to make sure that we had done was do some education on kind of a logical way in which to do it, a bit of ladder logic on some kind of a form from us where you can check some boxes, that kind of thing. And so I've put together kind of what I do, how I do it, in true checklist form, and I'm going to go through that with you right now. This is my strut system creation checklist. Add me back in the corner, and here we go. Things to consider are the run, and you can lay these out by list. It doesn't matter, length, location, label, however they're coming off of your takeoff, off of your drawings. One of the tough things is folks have been putting them on, the specifier has been putting them on drawings by just the element, the fixture being used, but not the strut itself, and all they've done is referenced channel. And the difficulty with that is we can have, say, a 60-foot of channel, and what all they're going to call out is, and I want 42 of these wall wash units. Okay. Challenge there is you can't power 42 wall wash units with a single power supply, so it's not a 60-foot run. It's probably two 30-foot runs, or possibly even three 20-foot runs to create 60 feet of wall wash. And that takes several items you're going to see in our checklist to get there. But you need to lay this thing out to start in the big scheme, and then remember you may have to break it down into smaller bites. Okay? Construction, are we talking recessed, which would be trimmer, trimless choices, and are we talking about feeding this from above the strut? It's an outlet box that's mounted right to the last segment of the strut run. Or are we going to do an end feed? The challenge with an end feed is it has a visual to it. You're going to see 6 inches of blank at the end of this run. So if you've got somebody who says, no, I want light from one or the other, then you can't do an end feed. You're going to have to do a top feed. Surface or suspended are the only two other choices. The component formula. These are what I just mentioned, the appropriate lengths to achieve our runs or our construct. This is a systemic decision. This is not widget. Strut is not, we don't sell 17 struts. Strut is a system, and you need all the pieces and parts to work together, so you have to think in systemic formula. Along with the standard lengths, I have a 22-foot on the long side with an L to an 8-foot on the short side, and I want the entire thing lit. We can't do 22 by 8. We can get close, but we can't do it because the L's, the T's, the X's, they all have a dimension to them. And so you're then going to have to cut in the field whatever your structural rest of your install is in order to get as close to those dimensions as possible, remembering that the strut itself has a dimension, a width value. So we might be able to get to 22 foot in length on that long side, but on the short side we're going to be off by 1 7/8 inches no matter what, because you have 1 7/8 inches in the width dimension of the fixture you installed in the long side to fill the channel all the way to the end. So just, you need to know and take the time to look at some of that dimensional information so that you can get as close as you can to what's being requested, and make sure you can educate your client consumer as to why we can't give them 22 by 16, 22 by 9. We can get very close, but we can't do that when you start talking about having to fill end-to-end, side-to-side. If we're not doing that, well, then it doesn't matter anyway, and we can get direct on, as long as we don't have to fill those corners. But keep that in mind first. If somebody comes to you and says, I want continuous light, end-to-end, side-to-side, you need to look very carefully and very closely at those dimensions, and we'll get as close as we can, but we're not going to hit them dead on. Otherwise, if we don't care about filling the corners with light, have at it, and I will get you your 22 by 16. All right? If we're using trig hubs, instead of corners, T's, that kind of thing. You're going to want to know the number of tabs that you're going to use and whether it's going to be just a feed, and that means power and data, or is it going to be just the suspension, which gives us both a structural and point, in kind of structural integrity at that point to lead off down the strut itself. And it gives us the ability to each one of those tabs to turn off and on power and data if we're using it as kind of an end to one feed area of power and the start of another feed area of power. We use power and dead-eye connectors both to achieve this construction that we're talking about. Biggest thing here is to say, remember that you can have up to 150 foot, and the numbers vary, but 150 foot of a construct. So if we're directly above our strut construct, then that rectangle can be 140 foot long. We have a 10-foot drop to the strut. We can have a 140 foot linear-wise rectangle. And that's great, and we can have that, long as we don't overload it. So the big thing there becomes loading, and now we have to use dead eyes to break up our structure in order to keep the dimension of the structure and appropriately power and data that structure. Suspension requirements. Are we doing aircraft cable? Are we doing solid stems? Are we attaching it to a grid? Are we suspending it within the grid? When it comes to grid, we have 5 choices of grid mounting. Those are clips and mounting structural pieces. We're going to want to know what kind of grid we're dealing with, and that decides those pieces. And then the element selection by type. And here we go in the types. Linear. What type of linear? Is it the regressed? Is it the surface? What are the lengths we want to use that best completes our construct? Color temp. If we're doing the surface version, not the regressed, not the architectural regress, but the surface version, do we want that to look continuous? And if so, is there a reason we need one additional piece of lensing? Very important to ask that question. Cheap, it's a cheap band-aid if somebody goofs. And every time we take an end cap out, you're going to change a dimension by a little bit. So you may need that one extra piece. Are we going to have uplight if we're talking about suspended? If so, what kind of output? What are we using it for? Is it actually contributing, or are we just kind of making the ceiling glow? Important part to remember is that uplight, choose up wattage. Are we filling the entire cavity available above? And again, color temp. The uplight driver count is going to be based on the number of lengths of strut. And apart from a 4-foot segment, you're going to need a driver in every segment. Driver's 9 inches long. So you're not going to order, if it's a 16-foot segment, well, we're going to go smaller, 12-foot segment. You're not ordering 12 foot of uplight. You're ordering 11 foot of uplight because there's a 9-inch driver at one end of the channel. You need to know those things, ask the question, figure out what they're doing with the uplight, and remember that that is wattage that's going to chew from our primary power supply. The spot fixtures. Which size? The minis, the full size? Excuse me. Fixed or adjustable for the optic, and then obviously the color temp. Decorative pieces. How big? We have multiple sizes for every decorative piece. Color temp, obviously, once again. And one of the things that I don't have on there is you can swag those decorative pieces off to the side of the strut. So do you need the swag hooks? And if you do so, do we need to put something next to the module powering the decorative piece so that we are addressing lighting below the channel where we have pulled that, swagged that fixture off to the side? Again, total wattage by run length for both the down and the up light, allowing 20% overage factor. That may adjust our construct. That may take us back to our power and dead-eye connectors. That will then feed to our CPU selection based on that total wattage. The control scheme that's involved. How many zone counts per run length? And are we getting creative in mixing and matching? Had a theater kind of a thing, to make it simple, picture that you had 16 feet and a bunch of track heads, and what they really wanted was the ability to control 8 zones. Well, what we did is we broke it into 4-foot lengths, powered each one with a 96-watt power supply, and in doing it that way, we had 4 zones per 4-footer. We every other the 4-footers, and when you look at that from a logical standpoint of the slide dimmers on the wall in the back of the room, it appears as if you have 8 zones. You don't really, but it looks like you do. So you can get creative with that kind of thing as well. Remember that we are magnetic low voltage, electronic low voltage, and a single 0 to 10 input, either of which can just be a switch, contact closure. We have multiple 0 to 10s totaling out at 4, so you can do up to 4 zones of that. And we have DMX. So remember that any of those are our choices, but you need to make that choice at the front end. It can be changed out in the field, but that's a little more challenging because you then have to rewire on the 0 to 10 side or add in the DMX side. It's something that needed to be addressed on the front end, but can it be done after the fact? It can. And I would encourage you to always use the multiple 0 to 10 for your CPU, simply because who knows when somebody says, no, I really would like to be able to use 2 different dimmers to control the track heads along with the downlight, or the uplight and the downlight. Last but not least, we're talking about the accessories, and these are accessories for everything from mounting to the elements themselves. If we're wanting to do something in a to lessen some of the glare or snoots or any of that kind of thing, these are all available, but try and get some idea of what might be wanted up front, and then we're not shipping it later. Or do know that you could ship all of that later and snap it in the field if so desired. That's the best part of a modular system. You can do and make changes after the fact. So folks, I thank you for your time. I want to try and keep this thing under 15 minutes, and I think we did. Looking for there it is, clock timer. So I hope this helped. You're going to receive this in an email that also includes those couple of useful documents I mentioned, and the secondary video, which is now more in-depth, taking the ideas, thoughts that are on this page that I'm giving you, and fleshing those out across an actual project. So I would encourage you to watch that one as well. So thanks for your time. Thank you for your attention. And any questions, obviously, call me right away. All for now.